Good morning, everybody. Today we're going to be looking at assignment number 3, which has a focus on geometry. We'll be looking at question number 1. In every quadrilateral, there is a hidden parallelogram. You can find it by joining the midpoints of the four sides. For example, in the diagram provided, if you join the midpoints PQ, RS of the sides of quadrilateral ABCD, then you'll obtain a parallelogram. Can you explain why this always happens regardless of which quadrilateral ABCD you start with? I'll give you a quick hint. You can find it by joining the midpoints of the four sides. The midpoints. Can you remember any type of theorem that we use that has a focus on the midpoints? Okay, so to begin, we can draw a line from A to C. So we can draw AC, which creates nice triangles such as triangle ABC and triangle CDA, where P is the midpoint of AB and Q is the midpoint of BC. So using the midline theorem, it will show us that PQ is parallel to AC and half the length. It will also show us that RS, since R is the midpoint of CD and S is the midpoint of DA, we can use the midline theorem to show that RS is parallel to AC and half its length, making PQ congruent and parallel to RS. Our next step is to draw DB. So if we draw DB, that gives us another more nice triangles. So BC, triangle BCD, and triangle DAB. Again, using the midline theorem, we can see that QR, because Q is in the midpoint of BC and R is the midpoint of CD, is parallel and half the length of DB. We can also see that since S is the midpoint of DA and P is the midpoint of AB, is parallel to DB and half the length, making PQRS a parallelogram as it has two pairs of congruent and parallel sides.